I am going to discuss about homogeneous and heterogeneous system. Homogeneous and heterogeneous system. So before going to this homogeneous and heterogeneous system, first of all we have to know what is phase. Phase, a quantity of matter homogeneous throughout in chemical composition and physical structure is called phase. Like example, water in liquid phase, ice is in solid phase, dry vapor is in gas phase. So every substance can exist in any of these three phases. So a system consists of a single phase is called homogeneous system. Example, water, ice. A system consists of more than one phase is known as heterogeneous system. Example, muddy water. So now comes to your reversible process. The process in which both system and surrounding return to its original position is known as reversible process. In this process, all state passes through a equilibrium state. See the PV diagram. So 1 to 2. So here first process is 1 to 2. Again it is reverse back. So 2 to 1. So forward direction and backward direction. So every state is in equilibrium state. Example, elastic deformation of solid. Then comes to your irreversible process. The process in which both system and surrounding does not return to its original position is known as irreversible process. See the PV diagram. Example, in elastic plastic deformation of solid. What is the cause of irreversibility? The first cause is friction. Due to friction, viscosity, elastic resistance, lack of thermodynamic equilibrium. We have discussed next another chapter. Okay, now comes to your what is thermodynamic equilibrium. A system is said to be in a state of thermodynamic equilibrium if there is no change in any macroscopic property registered when the system is in isolated with the surrounding, or a system is in thermodynamic equilibrium if it is satisfied following three equilibriums such as thermal equilibrium, chemical equilibrium and mechanical equilibrium. What is thermal equilibrium? In this equilibrium there is no heat transfer between the system and surrounding. If there is no heat transfer between the system and surrounding, then that is thermal equilibrium. What is chemical equilibrium? There is no chemical reaction or transfer of matter from one part to another part of the system. If there is no chemical reaction between the system and surrounding, that is chemical equilibrium. What is mechanical equilibrium? In which there is no unbalanced force within the system itself and also between the system and surrounding is known as mechanical equilibrium. Now comes to your quasi-static process. What is quasi-static process? If the deviation of the state from thermodynamic equilibrium is infinitely small, that process is known as your quasi-static process. See, it is a piston cylinder arrangement. Okay, here it is a piston cylinder arrangement. What happens when you remove? Here the weight is there, here piston, here it is the system where pressure, volume, temperature is there, here it is the cylinder. So in this piston cylinder arrangement, the weight are taken on the piston. Above the piston the weight is there. So when you remove one by one, now when the weight are removed from the piston one by one slowly, then the process is known as quasi-static process. When all the weights are removed suddenly at a time, then the process is non-quasi-static process. So quasi-static process is also known as a reversible process. So now it is the PV diagram. So quasi-static process 1 to 2, both forward and backward direction, because 1 to 2 is a process, then 2 to 1 is also a process. Every state is a equilibrium state. If it is a non-quasi-static process, then it is the PV diagram. Thank you.